Section 7.2, Inverses of Relations and Functions. The essential question: how do I find inverses of functions? So let's review a few things here. We know that the additive inverse of 3 is -3 because 3 plus -3 is 0. We also know the multiplicative inverse of 5 is 1/5 because a number like 5 times its reciprocal is equal to 1. You can also find and apply inverses to relations and functions. To graph the inverse relation, you can reflect each point across the line y equals x. This is equivalent to switching the x and y values in each ordered pair of the relation. So here's an example. Graph the relation and connect the points. Then graph the inverse. Identify the domain and range of each relation. So as you can see here, we graphed each of the points ahead of time. So for example, when x is equal to 0, y is 2. When x is 1, y is 5. When x is 5, y is 6. And when x is 8, y is 9. And then we just connected the dots. Now we're going to switch the x and y values in each ordered pair. So up here, the x's are now going to be y's. So 0, 1, 5, and 8. And the y's are going to be x's. 2, let's try that again. 2, 5, 6, and 9. And now let's graph those points. So over 2 up 0, over 5 up 1, over 6 up 5, over 9 up 8. Up 8 is about right there. And we're going to connect the dots. So let's get my little line out here to make it easier. So from here to here, from here to here, from here to here. And basically what happened is the blue line reflected over the line y equals x. So I'm going to do that right now. I'm going to try at least. Let's try that again. We got to start down here a little bit. There we go. Right there. That dashed line is the line y equals x. So this is the definition of an inverse. Each of these points, the blue points, were reflected on the other side of the line y equals x. Basically, that means we switch the x's and the y's. That's how you find the inverse. And so this is the inverse relation. We just switched x and y. So now let's talk about domain and range. So the domain is going to be all x such that x is going to be in between 0 and 8 because we connected the dots. The range, which is the y values, going to be all y such that y is in between 2 and 9. So what's going to happen now on the inverse, the domain is going to be the range of the original. So all x such that x is going to be, and all y such that y is in between 0 and 8. And we can see that by looking. Now the x's go from 2 to 9 and the y's go from 0 to 8. But notice the domain of the original becomes the range of the inverse. The range of the original becomes the domain of the inverse, and that's because the definition of inverses, you switch your x's and your y's. When the relation is also a function, you can write the inverse of the function f of x in this notation. You cannot see that well, it looks like that. This notation does not indicate a reciprocal, means inverse. Functions that undo each other are inverse functions. You find the inverse function by writing the original function with x and y switched and then solve for y. So that's what we're going to do. We're given a function. This is a relation. So all we do is switch your x's and your y's and we are done and we get the inverse relation. Here we go. All right. So f of x, remember f of x, another name for that is y. So we can write this as y equals x minus 1/2. We're going to switch the x's and the y's, and we're going to solve for y. And another way to write that y to the -1 doesn't mean the reciprocal. That's the notation for the inverse. This is the inverse of f of x. All right, next example. Again, I'm going to start by changing f of x to y, switch x and y, and solve for y. So we've got to multiply both sides by 3. They cancel. So we get 3x equals y. I like to put the y on the left side. And we're done. This is the inverse of f of x. Okay. Example 4. I'm just seeing. I'm going to save example 4 for class, and I'm going to go to example 5. We're going to graph this function, and then we're going to write the inverse and graph that. Great. So let's find the inverse first. So y is equal to -1/2 x minus 5. We have to switch your x and y. So now x, see. Okay. X equals -1/2 y minus 5. Solve for y. So we got to add 5 to both sides. So x plus 5 equals -1/2 y. To get rid of the -1/2, we have to multiply both sides by -2. And we get negative 2x minus 10 equals y. But again, to note that it's the inverse, we want to write it like this. Y raised to the negative 1, which basically just says this is the inverse. So this is the inverse function. All right, let's graph the original. We're going to graph the original in red. Let's remember how we graph. Well, we know that the slope is negative 1/2, and we know that the y-intercept is negative 5. So we start at negative 5 on the y-axis. 1, 2, 3, 4, 5. And we're going to go down 1. Whoops. Down 1 to the right 2. Down 1 to the right 2. Or we can go up 1 to the left 2. Up 1 to the left 2. 1 to left 2. Up 1 to left 2. Okay. And I'm going to move this because this kind of is in the way. Okay, come on. Let's go back like this. Let's just go times negative 2. Don't need to move it over so far. Okay. Up 1 to left 2. There we go. So now if I connect the dots here, I'll do that. There we go. Okay, now let's graph the inverse in blue. So the y-intercept's negative 10. So that's negative 5. Then we go negative 6, negative 7, negative 8, negative 9, negative 10. And that here we have a slope that's negative 2 and a y-intercept of negative 10. So I'm going to go up 2 to the left 1, up 2 to the left 1, up 2 to the left 1, and up 2 to the left 1, and up 2 to the left 1. And let's connect those dots here. All right. And there we go. And if I draw in the line y equals x right there, we can see that these are inverses of each other. They're reflecting over the line y equals x. That's the definition. We switch x and y's and solve for y. So let's just write one thing. I can just draw a line actually. Nope, that's not what I wanted to do. I want a marker. This goes with this one. And then we'll just, the red one. This is going to be y equals negative 1/2 x minus 5. And that's all we have to do. We're going to save this one for class. And here's your video questions. We're going to use inverse operations to write the inverse of the function. Switch x and y's and solve for y. And then what is your favorite season?